Hello everyone, welcome to Green IO. I'm Gael Duez, and in this podcast we empower responsible technologists to build a greener digital world, one bite at a time. Twice a month on a Tuesday, our guests from across the globe share insights, tools, and alternative approaches, enabling people within the tech sector and beyond to boost digital sustainability. Breaking news, which I'm sure you've absolutely never heard of. The rise of artificial intelligence, and more specifically generative artificial intelligence, and more specifically LLM-based products, might have an impact on global energy consumption, which might have an impact on several environmental indicators. More seriously, a few months ago, a report from the International Energy Agency estimated that AI-induced workloads in data centers account for around 180 million tons of indirect CO2 emissions today from the consumption of electricity, not including any emissions from backup power generation, not including the emissions caused by refrigerant gases, not including any emissions from the equipment, the so-called embedded carbon. Still, 180 million ton is a number to pay attention to. It is roughly 0.5% of all global fuel consumption CO2 emissions. The methodology and the data collection of this IEA report is heavily challenged by some specialists, but no one challenges the trend. It's going up. To discuss this topic, I welcome on the show today Iuna Tsyrulneva, who is one of the top experts in Southeast Asia about AI and sustainability. Iuna is a scientist holding a PhD in materials science and works at the Earth Observatory of Singapore with an interdisciplinary approach. Fun fact, her LinkedIn doesn't brag at all about AI. Yet, she happened to deliver one of the most consistent and comprehensive talks on AI sustainability at the latest AI Summit in Singapore. She's also one of the first announced speakers of Green IO Singapore 2026, which call for participant has opened a few weeks ago. But that's a different story. Welcome, Iuna. Thanks a lot for joining Green IO today.
Thank you so much, Gail, for such a wonderful introduction. I'm happy to be here.
I'm very happy to have you as well. And I really thank Thibaut for putting us in touch. Bouncing back on what I said in the introduction, I've got a very basic question. How did you start getting involved with AI? Was it from a practical angle during your PhD, more as a concerned citizen when you joined the Earth Observatory, or was it something else?
Thank you so much for this question, Gail. I guess my career path was not so linear. I think I jumped from one topic to another. So basically, I was trained as a chemist during my bachelor, and then I obtained PhD in material science. So there, I did not use AI for my research at all. So I was working on the development of biosensor for detection of fatigue. Completely different topic, right? But then after that, I thought that I want to do something that is more relatable to the society, to the community. I want really to study the impact of technologies on society and for public good. So I moved to studying the responsible AI and to researching it. I explored the governmental regulation of responsible AI in Singapore. So we provided the consultancy services to interview management in terms of what is the landscape of responsible AI in Singapore is. And sustainable AI was one of the topics that we covered there as well. Of course, there we mostly looked at how we can green the algorithms used for AI models, but we didn't cover that much of how AI can be used for sustainability or sustainable development goals. And this is something that we are going to discuss today as well. And then later, when I joined the Earth Observatory of Singapore in Young Technological University, I focused on exploring how AI can be used to achieve the environmental goals and how we can use it to assess the climate change impacts on the society.
Yeah, so two angles for AI and sustainability, and I think we will discuss the semantic of it. Now, you said something super interesting, and I know that the Singaporean government and people based in Singapore tends to be very hands-on and very practical when it comes to AI. You mentioned how to make AI models more energy efficient, and I think I've got a few dozen questions about it, but my first one would be, could you provide AI practitioners, so in a broad definition, with practical tips to make AI models more energy efficient?
Absolutely. And it's going to take quite a long time. Yeah. So please relax, bounce back on your chairs. Yeah, because it will take, it will take quite some time. When we talk about the sustainable AI, let's cover four main things that contribute to AI efficiency. First of them is algorithm optimization. A study from 2018 revealed that the computational needs to train large machine learning models have doubled every 3.4 months since 2012. This deviates quite a bit from Moore's law, which states that this should happen close to every 2 years, right? So you can see how big is energy demand for AI right now. So one of the most productive strategies in green algorithm development is the design of optimization techniques that reduce the computational resource management and thus they minimize the energy consumption. So we are going to cover four main techniques that are used for algorithm optimization. So first of them is actually developing computation efficient AI that uses compressed models, which are smaller, but they are still accurate. It can be done via pruning, quantization, and knowledge distillation. So these techniques can be applied in resource-limited systems, and by this, they accelerate the model accessibility on different devices. So first of all, what is pruning? Pruning includes the removal of neurons or weights that have the negligible contribution into the model accuracy. So it reduces the memory storage and computational power due to the decreased network size. Second is quantization. Quantization allows for speeding up the AI model performance due to transferring 32-bit floating point parameters into lower numerical precision of 16, 8, or 1 bit. So combination of these two techniques, pruning and quantization, in the models with similar network architecture leads to the more efficient AI model. And finally, the third one is the knowledge distillation technique, which is called teacher-student. And it involves this teacher-student pattern transfer for learned data. So both models have the similar architecture that facilitates the compatibility and flexibility. And the teacher model uses the extract of the knowledge, of the trained knowledge, and it passes it to the student model. So it makes student network more lightweight and efficient in operation.
Among all of those you listed, are there anyone that you will qualify of quick wins? And are there some that you've experienced being harder? Like, is quantization, for instance, easier to implement that prunification, or it really depends?
So I've been talking to a couple of corporate engineers, and so I've been asking them, is it really difficult to implement sustainable AI in some corporate settings, right? And they told me that sometimes it can be very difficult to change the entire code, the entire software that the company already uses. But where they can actually use the sustainable AI approach is when the big company acquires startups and acquires their codes, right? So the engineers usually are required to revise the entire code. And this is where they can make the changes that eventually lead to more energy efficient AI models. One of the changes can be everything that we mentioned, like pruning, quantization, and knowledge distillation. However, I feel that knowledge distillation requires a little bit more work, a little bit more of revising of the code, whereas pruning and quantization can be implemented quite easily because eventually it also leads to more computational efficiency and to less resources used in the cloud.
Okay, but that's interesting that when you've got already a large code base, and it's the same with, I would say, every code base, whether it's an AI driven product or not, you've still got some extra work to do to implement these techniques. There is another clarification question I would like to ask you is the energy gains, are they mostly during the training phase or are they mostly during the so-called inference phase?
There was a study, as a scientist, to speak from the position of studies and research that has been done. Researchers from Google and from the University of California, Berkeley, they have shown that the carbon footprint of large language models can be reduced by 100 to 1,000 times with the appropriate algorithms that also cover the customized hardware and energy efficient cloud data centers. So it can be done without affecting the quality of the AI models themselves.
Is it the energy consumed during the training phase, or is it the energy consumed during the inference phase that is reduced by these techniques?
I believe it is a combination of both. So the majority of energy is being used, of course, in the inference state, right? When a lot of users use the models. However, certain things, as for example, training the entire model in cloud, or maybe using various kinds of hardware, TPUs compared to GPUs or CPUs, right? So it all has an effect on the energy consumption during the training stage.
Okay, got it. Maybe my last question, and this one is a bit more specific because it doesn't come from me directly, but Wilco Berggraaf, who's a respected voice in the green IT community and a long-time fan of the show, mentioned an interesting fact in a recent discussion. Generative AI is slow. And by that, I mean, and that actually is super true. We're talking about less than 10,000 tokens per second, and we keep adding ways to, add scenes and like agentic MCP plugins, etc., etc. But do you see some synergies between what you listed as one of the main contributing factors to make model more sustainable and the design pattern in AI software engineering, I would say, to prevent bloat?
There is actually another idea of how to make the AI more energy efficient, right? And this is just using efficient ML model architecture, so-called like narrow AI, right? So we do not really need to use the foundational LLMs for any kind of task. So the more narrow the task is, the smaller the model is, right? And the less energy it requires and the less parameters it requires to be trained on. And this can actually lead to the lower energy consumption.
Fun fact, because there was another discussion about the wording with Maxime Fazilo, the co-organizer of Green Eye London. For you, this word narrow AI, is it similar to the word frugal AI? Because we were discussing that the word starts to pop up here and there. Is it a word that you use? Is it the same definition, or narrow AI, frugal AI, whatever AI?
I believe actually this is the first time when I hear about frugal AI.
Okay.
But that's somehow I think I would attribute frugal AI to more like energy efficient AI, because it means that sometimes it cuts on certain functions, sometimes it cuts on the accuracy, but what it prioritizes is the computational efficiency. And then it means it doesn't go like very luxurious. It cannot serve many purposes, but still it does its job and in a very efficient manner.
Thanks, Iuna, for answering all these questions. If I understood you well, the first big topic is all about algorithm optimization, quantification, pruning, etc., etc. Narrow AI. Is there more, or is it only about algorithm optimization?
So let me add more on algorithm optimization, because this is actually not enough. So some of the approaches that are currently used is actually using the lower level programming languages, because they have fewer memory management requirements and thus they are more energy efficient, right? So this is, for example, using C and assembly versus Python and Java. I understand this is quite a big requirement, and initially the entire software development has to be planned with these requirements in mind. But this is something that can have a huge impact on the energy demand of AI model.
And is it something that you've seen? Like, is it the sort of best practice that people write saying, okay, we should do that, but it's never done? Or did you see with all the interactions you've got in the Singaporean ecosystem, companies starting to use C or assembly language or rewriting piece of code to tremendously increase the efficiency? Or is it just, a wish list?
There have been some comparative studies that highlight the energy efficiency of lower level programming languages, but from my experience, I've never heard anything like that being implemented in Singapore or in any other countries. This is still in pipeline.
Yeah. Okay. Thanks a lot. Because the cost, I mean, I used to be a CTO, and whenever someone told me you need to redevelop everything with a new language, I was like, are you kidding? I mean, usually it's just when you need to make a major improvement to your platform or simply restart an entire product or set of features, but because the change in the needs or in the way you want to implement them then might justify switching the code. But switching the code for the sake of efficiency, even like regular performance, I would say, usually doesn't cover the cost of training your workforce, etc.
Yeah, this sounds crazy. Yes, I agree. And that's why I believe that everything should be done since the very beginning, right? So the sustainability principles should be implemented and discussed and spoken about just at the very beginning of the software development. So it should be put at the fundament, the basis of the software.
That's a sound advice. Thanks a lot for this, starting with sustainability in mind from the start. You mentioned algorithm optimization. Is there more to add on algorithm optimization, or do you also want to list other things to enable more energy efficient or actually more sustainable AI models?
There are two more points that I wanted to add. So first is actually promoting open source resources, because currently software development ends up becoming energy efficient due to continuous development process, right? So tapping on reusable open source components can remove the need to develop the AI models from the scratch every time. And this is actually where Singapore walks the talk, because Singapore government encourages using the public and open access models for the development of other applications. We have even the database where like everybody can get the access and they can use for their own purposes, right? And finally, the last point that I also wanted to highlight is so-called red AI. Red AI is actually where the higher accuracy is preferred over the energy efficiency of the model. So the analysis of 60 papers presented at the most prestigious computer science conferences showed that up to 90% of the works prioritize accuracy over efficiency. And if you think about this, do we really need, in the majority of cases, to have like 95% accuracy, that triples the time needed to provide a result with 75% accuracy, right? Which is already much higher than the accuracy of the result provided by human. So we also need to understand what kind of tasks we are doing and whether we need to use like high precision models. So this is all that I want to cover about algorithm optimization.
An entire new field, or not an entire thing, but a way to re-implement things that were already discussed previously in software engineering, but with this very specific AI loop. But I guess it's not all about algorithm optimization. Is there any other tips that you'd like to share with AI practitioner to make AI more sustainable?
So we have spoken about the algorithm optimization, and then the second point would be hardware optimization. So choosing more computationally efficient hardware can also contribute to energy savings. As for example, some GPUs have substantially higher efficiency in terms of floating point operations per second per watt of power usage compared to CPUs. Other specialized hardware accelerators are TPUs, tensor processing units, tailored specifically for machine learning tasks, and they give the ability to customize machine learning models to be used in specific hardware. Another important approach to hardware optimization is parallelization. It's a way to reduce the training time of algorithm by distributing computation among several processing cores. Of course, it needs to be done in a very thoughtful way.
Just about parallelization, as it requires more equipment, how do you see it as a potential benefit from a sustainability angle?
I look at this problem from the data management perspective, because sometimes what happens in data centers that cores that are supposed to use for certain tasks are idle for a while because there is no computation happening over there. And instead of keeping them idle, so it's better just to parallelize another process so that it can be run faster and in a more efficient manner.
So it's really using wasted resources rather than trying to achieve a faster training time.
In a way, yes.
This parallelization technique, for you, is it mostly during the training of the model, or is it also something to consider when the model is being used?
Good point. I believe that it's easier to control it when the model is being trained. However, I think in certain instances, it can be used during the inference, but it requires a little bit of planning. And I haven't heard about the instances when it is used right now.
Me neither, hence my question. Sorry, I interrupted you. So you also wanted to mention other hardware optimization techniques.
Yes. And finally, we are moving to the edge computing. This is also a key strategy in this context, as the idea to perform computation and allocations where the data is collected or used. That's avoiding the time to transmit the data from a data to a data center to the cloud. So this is currently what is being implemented on our smartphones, right? So the data being collected at the locations where we use it and it's being processed right on our smartphone. It also adds more to the security of the data and preserving the privacy.
So I've heard that sometimes good old CPU can do the job as well. So do we always need to chase the latest GPU, which happens to be most of the time the most energy efficient, yet very energy consuming, rather than CPU being at idle state? It seems to be a trade-off between CPU and GPU and energy efficiency.
Yes, currently, I believe a lot of machine learning scientists are working on GPUs, right? However, if you're not working with image processing, then maybe use of GPUs is not that required. I also know that a lot of engineers can use tensor processing units when they train neural networks and when they develop the AI models. However, GPUs are proprietary model owned by Google. So only if you work with Google notebooks, right, so you can actually choose to work on GPUs. This also requires certain agreements and certain willpower and action from the management of the company that you're working at. So they can promote the implementation of these regulations on what kind of GPUs you can, or what kind of processing units you can get access to and to work on.
So thanks a lot for the clarifications. We're done with hardware efficiency, but you also mentioned a third point, which is data center efficiency. After algorithm optimization and hardware optimization, there is also data center optimization. Am I right?
Yes, correct. Yeah. So let's talk a little bit about data center optimization, right? So we all know that with every new AI innovation, energy demands increases, and this often results in the Jevons paradox, where the improvements in energy efficiency lead to greater overall energy consumption and not to less. So this paradox actually highlights the need for energy efficient data centers, right, that are powered mostly by alternative energy resources. So the carbon footprint of data center is directly proportional to its efficiency and to the carbon intensity of the location. So with regards to this, you may want to think about the carbon footprint of data center that is located in Norway, for example, or where the total carbon footprint would be less than 20 grams of CO2 per kilowatt hour, and compared to Australia or to several US states where the carbon footprint will be over than 800 grams of CO2 per kilowatt hour. To address this, we can optimize, first of all, data center siting. We can increase the demand flexibility and load shifting, depending on the needs of the population the data center serves to. It would be definitely beneficial to move to the renewable backup generators and actually to renewable energy. Then some researchers speak about the introduction of modular infrastructures that enables the scalability and flexibility and actually the mobility of certain blocks, and it will be easy to reassemble data center in any point. And of course, the use of sustainable materials and techniques is also highly encouraged in data centers. But also researchers have developed the algorithmic frameworks that dynamically manage the server loads. They adjust cooling systems and they optimize the resource allocation according to the tasks that are submitted to the data center. So this would be the main technical approaches to data center optimization. And actually, there is one of my favorite examples, which highlights most like creative approach of how you can use data centers for good. There was this thing that happened in New York. There was a data center that was underground, and then there was a lot of like heat emitted by the functioning data center, right? What one of the entrepreneurs did, they constructed the sauna center on top of the data center. So they used the heat produced by data center to warm up the swimming pools and their spa facilities. I love this creative approach, and I guess that there is a lot to be done in this area as well.
Heat reuse is getting traction in cold countries, but that's the first time I heard about a sauna being powered by a data center. It's quite fun.
Yeah.
Now, Iuna, you mentioned right from the start the Jevons paradox, and this is music to my ear. What I didn't fully understand is the connection between the Jevons paradox and all these techniques regarding data center optimization. As far as I understood, Jevons paradox is more about how we cap the demand, because otherwise it will bounce back over and over and over.
Yes, I believe in this context, when we speak about the Jevons paradox, right? So we mentioned that with more and more AI models being introduced, as much sustainable as we make them, still energy consumption will increase over time because just more models come to the market, right? And we use them more and more. So what could help is actually optimizing the data centers, and we can make green them by introducing the variety of different techniques.
So it's like Jevons paradox will happen, and to tackle this, it's not about making it not happening, but making sure that this extra consumption of energy is managed as nicely as possible by data centers and via data centers optimization. Okay. So algorithm optimization, hardware optimization, and data center optimization. This is your three pillars. Is there anything else that we should consider to make AI more sustainable?
I think we have already covered the AI developers, then we covered the data centers, and finally, maybe we can talk a little bit more about the users, the final users, and how we use the AI models in a more sustainable way, right? Because also a lot of things depend on us. So maybe what can be done here from the perspective of a regular person? So we can just limit the number of times when an algorithm is run. So this is like undoubtedly the easiest way to reduce energy consumption. So maybe we don't need to go to AI anytime we seek some information. Another possible strategy would be to use less exhaustive searches. Maybe we don't need that detailed information all the time. For example, we do not need to use deep search offered by LLMs if everything I need is just the list of the landmarks in Singapore, right? This can be easily searchable via the net. Then one of my favorite points, so like a lot of people used to say thank you to any kind of prompt response offered by LLM. I understand they want to be polite, and just in case machines arise, that the AI will always remember that this specific person was respectful towards the machine. So my suggestion here would be just to say something like, okay, for all your future responses, I feel grateful, so I will not thank you anymore, but just please accept it right now. And then just stop thanking to it. Also, something that personally boggles me is AI-powered search offered by Google. For example, every time when I'm searching something like quantum computing, what I want to see is just like a Wikipedia page, right? So if I want just to get general information, but I do not need AI overview, which basically just cites references Wikipedia page. There should be some option to opt out of AI overviews in search engines.
And that's a very important point because we don't have that much choice today. I mean, there's been a study in France about how embedded AI is in today every tech product or digital product, and that opt-out option is not that much on the table. It's really like pushing AI through every product, whichever they are, and no really matter if we need them. How do you see a change in the trend, or is it even possible? Because we tend to put a lot of guilt on the end user, and they do understand that there are some issue with using AI for everything. I mean, when people are slightly aware of energy challenges and climate change crisis, etc., etc. But we don't have that much of a choice.
I believe still we shouldn't give up because we have choice, right? There are some other search engines that we can use. For example, Ecosia. As far as I understand, it doesn't provide any AI overview, right? I'm not sure about Bing. I think it does that as well. But we can always go deeper and conscious choices of the products that we use. For example, even if we need to use LLM for simple search for ChatGPT, right? Let's assume we have a choice of various models used to reply to our question, to our prompt. Just if you don't need that detailed response, if you're looking for something simple, or maybe if you're looking just for the social partner with whom you can spend time, you can just unselect the button that offers you deep search. These are simple ways of how we can reduce the power consumption, the energy consumption of AI models.
But it's not always possible. But at least when we have the choice, we should opt out when it doesn't make sense, obviously. Now, because time is running out, there is a fun fact that I would like to share with you, and that connects with something you mentioned when we were preparing the episode. Pascal Joly, another fan of the Green IO show, attended the latest San Francisco Climate Week. He lives there. And he told me that 95% of the talks were about how AI will solve climate crisis, and less than 5% was about its environmental impact. And I guess this is a good starting point to discuss the difference that is very keen to your heart between sustainable AI and AI for sustainability. So could you elaborate a bit on it?
So maybe something that we can just conceptualize here is that green or sustainable AI mostly stands for the algorithms that maximize the energy efficiency, right? And AI for sustainability supports the use of AI to respond to different environmental challenges. So now we are going to talk a little bit more about AI for sustainability, right? Researchers analyzed the impact of AI in accomplishing the United Nations SDGs, and they found that AI, by technological enhancement, has the potential to empower 79% targets across all SDGs, with the most positive effect, around 91%, observed in achieving environment-related goals. So 35% of these SDG targets may be subjected to negative outcomes from AI applications, with society-oriented goals being the most affected, more than a third of them. So despite heavy energy consumption, AI enables breakthroughs in the various areas across climate and energy sectors, and it accelerates climate research at scale. Right? So recently, Google's DeepMind has discovered around 2 million crystal structures, including 380,000 stable materials that could power batteries, computer chips, and solar panels. And now you can ask, like, so what? But this discovery is actually equivalent to about 800 years worth of knowledge it demonstrates the scale and the level of accuracy in predictions. So you can save like a lot of manpower hours on this. Then the International Energy Agency, in its report, outlined the industries where AI is already used in the way that it can help limit emissions, including detecting the methane leaks in oil and gas infrastructure, which contribute to the methane and to the general greenhouse effect. They make power plants and manufacturing facilities more efficient, and they reduce energy consumption in the buildings. So we work a lot with AI and sustainability at the Earth Observatory of Singapore. And as a part of climate transformation program, we apply AI to forecast the atmospheric changes, identify trends in climate variability, and optimize mitigation strategies. So our scientists utilize satellite-based damage mapping after disasters, and this enables the detection of anomalous surface changes based on the difference between forecast and observed co-event coherence. They also examine the processes underlying the biodiversity change through climate change in Singapore and Southeast Asia. We also apply machine learning mechanisms to analyze patterns in vegetation health, in deforestation rates, in urban expansion, water source availability, and other key indicators of environmental sustainability and unsustainable practices. So, and moreover, like utilizing AI, we address climate risks across various domains, including agricultural insurance, flood risk modeling, catastrophe bond pricing, and mortality risk. So you can see that AI can be also used in application as climate and finance and climate and health. And these are some of the examples that can deploy AI to address the issues of sustainability.
And there is a lot to unpack in what you said, and I've got several questions. My first one might be, so let's put aside the Jevons paradox. We already talked about it, but it tends to have a quite huge discrepancy between what was forecasted 10 or 20 years ago about IT, and now you can change IT by AI, and how it will help improve efficiency, more than efficiency, also increase sustainability and help us reach our sustainability goals, and what has been actually delivered. So my question is, did you already spotted examples where it works, rather than some reports say it might work and it might save, it might make the commercial fleet more efficient, it might make road transportation more efficient, but eventually with the Jevons paradox, we don't really reach this overall level of efficiency. So did you already spotted example for AI where actually this is not true and the efficiency gains are substantial and are not offset by the Jevons paradox?
This is a very interesting question because as a scientist, I would prefer to see a research paper that compares the achievements to sustainability, as a consequence of Jevons paradox. So for example, imagine that you wake up to a notification on your smartphone that tells you that in the next 48 hours, there will be a cyclone approaching the Southeast Asian shore, for example, Macau. So you have 48 hours to evacuate or to hide somewhere, right? Or to protect your assets. So far, currently, we do not have this capability of predicting the development of extreme events that far in time. But eventually, AI has the opportunity, has the chance to build the good forecasts for the events, and it can help save the lives and bring a lot of economic benefits to the society, to the communities that live along the shore.
And that's a very interesting example because I'd like a clarification from you which kind of AI are we talking about? Because in the general public mindset, I would say AI equals ChatGPT equals generative AI. And fun fact is, so far, but please do correct me if I'm wrong, most of the practical examples about AI being used for sustainability are not that much in generative AI, but like good old AI, I would say like machine learning, and obviously benefiting from all these new techniques, all this improvement in existing models or new models, but it's not that much about generative AI. And of course, it also benefits from all the hardware improvement that we've seen over the past years. But I'm struggling to find example where generative AI is that much of a use, except maybe the example you provided with the crystal. And you said several hundred thousands of new crystal being found, and some of them which might be used in battery development. But am I right or completely wrong to state that actually most of the AI used for good from a sustainability angle is mostly non-generative AI.
When you ask how do we call that specific AI if it's not generative AI. So my approach to that would be just considering this as machine learning with decision-making properties, right? So this is what we say. We use statistical models to predict or to analyze the development of extreme weather events. And then the decision-making power of AI actually thinks whether it should inform the community on the shore. How big is the risk? What is the certainty of these events approaching the seashore? So that would be my response to your first question. Can you briefly repeat the second one?
But the second one is how much of generative AI is actually being used, or is it just good old machine learning AI, things that we've been doing previously to all this generative approach? It's a bit like large language model versus good old machine learning model.
Currently, generative AI is just 3 years old, 2-3 years old. A lot of agentic AI tools are being developed to be implemented for climate science, but so far it is not that widespread. What we use instead is something that we call hybrid AI. This is the combination of physics-informed models with big data. This is how we tap on the strength of fundamental science, and then we use our access to the big data collected from the various sensors across the world, and we make the predictions for certain events based on these models. So far, generative AI is mostly used for detecting the misinformation in climate science communication.
Which is a fun fact because it helps both sides, because it's also widely used to spread misinformation as well, with fake videos and generating climate deniers posts and that kind of stuff. So it's a bit like a neutral weapon provider, I would say.
Yeah, this is true. So far, the research mentioned that good old LLMs, ChatGPT or Anthropic or Claude, right? So they provide right information about climate science so far.
So far.
Yes.
Thanks a lot, Iuna, for all this clarification. You already mentioned quite a lot of reports and sources. If people want to deep dive a bit more in these topics, whether it's sustainable AI or AI for sustainability, would you have some sources or other books or videos or whatnots to share with them?
Absolutely. So two of my favorite materials have been produced by Tony Blair Institute for Global Change. One of them is called Green AI Policy Agenda for Artificial Intelligence and Energy Revolutions. And you can find a lot of global and Singapore regulations put in place to regulate sustainable AI. And another one is also produced by the same institute and is called Responsible Progress Sustainable AI, the benefits of greening our digital future.
I will, as usual, share all the links to the resources you've mentioned, including these last two. And my final closing question, and I'm sure you're pretty well aware of it, do you have any positive piece of news to share about sustainability and maybe AI for sustainability or sustainable AI to close the podcast and finish on a positive note?
I try to stay optimistic since the very beginning, right? So when we spoke about the energy consumption of AI, we mentioned that it's not that bad, still not that bad, right? So I understand that it's a snowball and we are moving very fast into the huge energetic catastrophe. But yeah, so far we can do something, and that gives us some optimism. So basically, as a researcher, I acquire an idealistic and tech optimistic view of the future of AI's role in sustainability. And as far as I'm working in this, I'm invested in making the good use of AI for achieving sustainable development goals. And the good thing is actually that in the course of past years, I've been talking to various corporate engineers who share similar optimistic views with me. And I see that the issue of energy-dependent AI is usually on the tables during the discussions. It is recognized and acknowledged by the practitioners. We also see that some governments are fast-tracking the adoption of energy-efficient data centers, and they create the roadmaps for the introducing more sustainable AI practices. So I assume that awareness, understanding, and knowledge are already there, and this gives me hope. So what is required to do is just to nudge the C-suite to adopt sustainable practices or sustainable algorithms, and either through financially profitable approaches or maybe by changing the entire sustainability frameworks, maybe adjusting KPIs, for example, like introducing the index of energy per AI use for industries, or maybe through the regulations imposed by governments, maybe a harsher approach by the governments to nudge the industries to adopt the sustainable practices.
Yes, thanks, Iuna, and thanks for remaining optimistic. And actually, if you indulge me to bounce back on what you said, I know it is supposed to be closing words. We didn't mention that much of financial incentive, and you just did. From a C-suite perspective, the savings from energy efficient models is not always enough to offset the time opportunity loss, I would say. Like basically it's like, let's launch an AI product, whatever it costs, whatever it can drain energy or impact or sustainability KPI, because we need to be first in the market, because there is such a big hype at the moment around AI that we need to have something labeled AI, blah, blah, blah. And sometimes it's not useful, sometimes it's not really well done. How would you tackle this product? Is it only via regulations and enforcing more sustainability goals, or do you believe that there is also some sort of discussion that can happen with executives regarding this trade-off, like long-term, short-term, and let's do AI, let's do AI?
Thank you for this question. I don't really want to take over the sustainable business leaders and the experts in that area because I don't quite work with the businesses and industries. I do not know how they implement everything. But my take on this, because we work at the intersection between research and industries and governmental agencies, right? So we are providing the knowledge that is supposed to be adopted by the industries and implemented for the better use. One of the approaches is, of course, to involve the researchers into the discussions quite early. Either they're in-house researchers as engineers or they are university researchers, because we afford ourselves to be more idealistic and to think about the problems of sustainability at a higher scale. We can provide this knowledge to the decision makers. We can teach them or advise them on how to develop sustainable algorithms from the scratch. So this can be one of the approaches. The second approach, as I mentioned, what happens during the acquiring of a startup by a bigger company, right? So the code is always revised. There could be some regulations, some requirements for that code to be more sustainable, a little bit more sustainable. That can also encourage the new startups to develop more energy efficient, sustainable codes or algorithm if they want to have like a good exit strategy, something along these lines.
Thanks a lot for the answer. And thanks a lot for joining Green IO today, Iuna. It was very packed with
I hope it makes some
insights.
sense.
It was almost like a full report. So very interesting. Thanks a lot. Yeah, and truly looking forward to seeing you at Green IO Singapore 2026, and it will be in April.
Thank you. I'll be happy to participate there.
Thank you for joining the show.
Thank you for having me, Gail.
Thank you for listening to this Green IO episode. Because accessible and transparent information is in the DNA of Green IO, all the references mentioned in this episode, as well as the full transcript, are in the show notes. You can find these notes on your favorite podcast platform and, of course, on our website, greenio.tech. If you enjoyed this interview, please take 30 seconds to give us 5 stars on Apple Podcast or Spotify. I know it's not easy to find the feature on these apps, but I trust you to succeed. Sharing this episode on social media or directly with AI practitioners in your network is also a good idea to provide them with practical tips on how to reduce its footprint. You get the point. Being an independent media, we rely mostly on you to get more responsible technologists on board. In our next episode, we will have an amazing discussion between two rock stars of the green IT field, Mark Butcher and Vilko Bergraf. They didn't agree on everything, but they dived into every Gen AI rabbit hole that I can assure you. Stay tuned. By the way, Green.io is a podcast and much more. So visit greenio.tech to subscribe to our free monthly newsletter, read the latest articles on our blog, and check the conferences we organize across the globe. London was a blast last month, and the next one is in Paris on December 9 to 11. As a Green IO listener, you can get a free ticket to any Green IO conferences using the voucher Green IO VIP. Just make sure to have one before the 30 free tickets per conference are all gone. I'm looking forward to meeting you there to help you, fellow responsible technologists, build a greener digital world.
One bite at a time.